Hey, grade nines. So I'm going on to the worksheet that was given to you. First one says, prove that triangle ABC is similar to triangle DEF. Okay. They've given us that this line is parallel to this line. So what I want to do is just highlight those two. So it's a reminder to us that they're parallel. And I probably suggest that you guys do this as well. It just helps just to see that those lines are parallel. Okay, so we have those are parallel. They've given us that angle E is 90 and B is 90. So how I'm going to do it is I'm going to write it down how they've given it to us. So in triangle ABC and triangle DEF, we need three things for similarity. So the first thing I'm going to say is angle B is equal to angle E because they're both equal to 90. So this angle B lies in this triangle and E lies in this triangle. So we have B equals E, both equal 90 degrees. That was given to us. Okay. Now, the next one I'm going to do is I'm going to say this angle C1 is equal to this angle F1 because I'm going to use my parallel lines. And you can see here we've got that Z. It's making that Z over there. And the Z is alternate angles. So C1 lies in this ABC triangle. So angle C1 equals angle F1. My reason here, alternate angles. And I must just state which lines were parallel. So AC parallel FD. Okay, so let's do the third one. We've got the B, we've got the C, BC. We just need the A is equal to EF. We've got the E and the F, we're just missing the D. And my reason for that, third angle of triangle. Okay, therefore, triangle BCA, similar triangle EFD. And that's all they wanted from us, just to prove that they were similar. All right, question B. Question B is asking us to prove that triangle, so I just want to put this down as a note, prove triangle PQR similar to triangle PTS. Okay, so that's what they're asking us to prove. And what we've got here, and they're going on to say, reasons need not be given. Okay. And we have been given a whole bunch of lengths here for all these sides. So what I'm going to do is I'm just going to draw a very rough thing. It doesn't have to be perfect, of the two triangles. So I'm looking at PQR. PQR is the smaller one. So I'm going to draw a very rough thing of it. Like that. Where that's that is Q. That is P, and that is R. So PQ is 5, PR is 4, and then RQ is 6. Okay. Now I'm going to do the PTS triangle. PTS, which is the big one. Again, guys, just very rough. And it doesn't have to be to scale. Okay. So we have P, T, and S. So let's have a look at the side PS. PS is this entire length here. So it's 5 and 3. So 5 plus 3 gives us 8. Then we've got ST. ST is 12. And then we have PT. PT, so that is 4 and 6. 4 plus 6 is 10. Now what I'm going to do is I'm going to compare this to information that they've got here for both these triangles. So if I have a look here, and I'm just shooting here, okay, guys, just checking. From 6 to 8, what did I multiply 6 by to get to 8? Well, let's have a look, see. So if I take 8 divided by 6, we get 1.333. So if I multiply 4 by the same number, so if we say 4 times that same number, because I just want to see which sides are in proportion. Okay, so we've tested this one, going to that one. Now I'm going to see which side this corresponds to. So 4 times that thing, and we get 5.333. So we don't have a 5.333 in this triangle. So mapping this side to that side is not a good choice. Okay, let's do the same thing from this side to that side. What did I multiply 6 by to get to 10? Well, we just say 10 divided by 6. Okay, and we get 1.66666. So mapping that to that, we get a scale factor of 1.6666. I'm just going to test this one. So we're going to say 4 times that number that we just got, and we get 6.6666. I don't have a 6.6666 here. Okay, so that is a bad choice. Let's have a look at mapping it from here to here. So 6 times what gives us the 12? Say 12 divided by 6, and we get 2. Now I'm going to multiply the 4 by 2. So 4 by 2 gives us 8. There's an 8. Cool, so that's working so far. If I multiply that one by 2, we get 10. And there's the 10. Okay, so our mapping is this side. Let me do it in color for you. This side corresponds to this side by a scale factor of 2. This side corresponds to, this side corresponds to this side by a scale factor of 2, and then 6 goes to this one. Apologies for that, grade 9s. And then we've got our last one. This one maps to this one by a scale factor of 2. Okay, so we have proved that they are similar because the corresponding sides are in proportion. They're not asking us for a proof, okay, or a reason. But what I can say here is I can say that 2 times QR is equal to, so it was 2 times QR equals ST. 2 times PR is equal to PS. And then 2 times PQ is equal to PT. Okay, and because we're getting the same scale factor of 2, 2, 2, it is similar because sides are in proportion. All right, and you saw I ran through all the other numbers, like we were getting 1.333 and then 1.666, and they all differed. Okay, so the sides were not in proportion, but because we're getting this constant number over here, the sides must be in proportion. Okay, thanks, grade 9s.